Okay, so today we're going to go through the virtual lab for gas laws lesson 1. It's going to be just kind of looking at a lot of the basics for the gas laws unit. If you look in the lesson and scroll down, we've already watched the video, we took a couple notes, and then here we are at the virtual lab. So these are the questions right here, this 1 through 6, that you're going to be answering. So I would like for you to copy them into your text entry box, or copy them into a Google Doc so that you can answer them and then submit them as the text entry or as a PDF from your Google Doc. Okay, so here is the virtual lab. I'm going to go ahead and put mine full screen so that we can see it a little bit better. And all right, so whenever you come to one of these virtual labs, you want to make sure that you check it out. Make sure that you understand what the virtual lab is doing. So here we have an ideal, an explore, energy, and diffusion. We're going to be looking basically at ideal, energy, and diffusion. And to start with, we could use the explore. The explore and ideal are very similar, but I'm just going to start there. And I need to reset mine because we had another class earlier. All right, let's look and see what are the things. Whenever you come into these virtual labs, make sure that you check out what are the things you can change. I can change the size of the box. We're going to start with it really small. I can change the units on temperature and pressure. I have a heat and cold, so I can add heat or put ice against it so that heat will be taken away. I can look at the particles, so I know I'm going to have a heavy and a light particle. I can change those that I'm putting in. And then I can hold things constant. Right now I just have volume held constant, which takes away the little handle. But your first question says open gas properties and then use the pump to put a little gas into the box. Observe the gas particles behavior. So you need to put something about that in your answer. Pump in some lighter particles and talk about the similarities and differences that you see between the heavy and light particles. Use the simulation to see how changing the temperature affects the behavior. Write a description for your gas based on your observations. All right, so pump in some gas. Do 2 pumps. All right, notice the pressure immediately went up when we added particles. The temperature is at 300 Kelvin. Okay. And so your questions say observe gas particle behavior. Then it says pump in some lighter particles and talk about similarities and differences that you see between the heavy and light particles. Okay, so we want to switch to the lighter particles and we'll do 2 pumps too. What do you notice? Looks like they're smaller. It does look like they're moving a little faster. I want to kind of really take that into consideration. And notice that on the side here, our hold constant has changed. So let's kind of explore the Avogadro's number. And let's hold pressure constant and see what happens as we add. And we went to put some parameters on there. Let's look at the width, and we don't need the other 2 really, but here's what happens. As I add in more particles, that volume increases. So that kind of proves what we looked at earlier. The more particles there are, the more space is needed. Right? And then what else? Back to our questions. It says use a simulation to see how changing temperature affects the behavior of the gas particles. All right, well, let's add some heat. Oops, the pressure cannot be held constant. All right, so let's go back to holding nothing constant. Okay. If I add heat, what is happening to the pressure? It goes up. And we lose our lid. Okay, what if I cool it off? What if I put ice against it and remove heat? What happens to the pressure? it goes down, right? Notice that, what are the particles doing? They're moving way more slowly. So let's see that again. If we add heat, what are the particles doing? They're speeding up. They're moving faster. So then it says, write a description for a gas based on your observations. So definitely adding heat is going to speed up the molecules of gas. Okay. Adding molecules is going to increase the volume. So we want some good statements like that in that answer. So I'll give you a couple of seconds to answer that. Go ahead and reset our system. All right, let's go ahead and look at number 2. It says, how could you increase pressure? List the ways that you can make the pressure go up. So first we need some particles in order to have pressure. So we'll go 3 pumps of gas. All right, so we have all these things we can change. If we make the volume bigger, the pressure goes down. So if I make the volume smaller, what does the pressure do? That's going to be one way that you can make pressure go up. What if I heat it up? That makes the pressure go up. And the other thing we can change is adding. So if I add gas, for every pump, I'm going up a measurable amount. So increase the volume, the pressure goes down. Decrease the volume, the pressure goes up. Increase the temperature, the pressure goes up. Decrease the temperature, the pressure goes down. Okay. So go ahead and answer number 2. All right. So number 3 says, determine the size of heavy particle using the simulation tools, and then relate molecule size to something you are familiar with. A common way to relate 2 things is to say something like 1,000 particles of sand fit into the palm of your hand. So we want to look at the heavy particle. Now this one is kind of arbitrary, okay? So we're looking at the heavy particle. Okay. And kind of just want to compare it. So we'll look at the light particle too. Is it twice as big? Is it slower? Is it... Okay. You can just write anything you write there, I'm going to give you the credit for, because it's such an arbitrary question. But it just really wants you to look at the size, because the next question is going to start, or in the couple questions, number 6 is going to start asking about energy. So it wants you to compare those sizes just visually from the screen. And then, no, wait a second. Number 4 says, how does the pressure change when you change the number of particles? So we kind of already answered that question in what we were doing, but if I add a bunch of particles in there, what happens to the pressure? More particles I add, the greater the pressure it is. And I just really like to make the lid come off. Okay. So then number 6 says, click on the energy tab. So we're going to click on the energy tab. I set that. And you want to notice you have average speed here, speed in a graph, and then kinetic energy in a graph. You can see your particles. You can see the injection temperature. Okay. You can change the temperature again. All right. So I want to see the graph for both of the heavy and the light particles. And then the question says, how is kinetic energy different in smaller particles? How does the speed compare between lighter and heavier particles? Well, first, let's get some heavier particles in there. Notice this average speed is like 500 meters per second, about that much. You can see in the graphs, the speed kind of fluctuates. The kinetic energy. All right, let's add some of the lighter particles so that we can compare. Look at the difference in average speed for the lighter particles. Heavier particles are like 440. Lighter particles are like 1200. So it's a big difference. Then when you look at the kinetic energy, okay, we're seeing the graph very similar. Those blue and red lines are very similar to one another. How is that possible? How is it that if they have similar kinetic energy, they have a very different speed? You want to think about mass, okay? It takes a lot more energy to move that mass. Think about a dump truck versus a race car or a sports car. They might have this, they probably don't, but they might have the same gas in them. But that dump truck is not going to accelerate. It's not going to move as fast as that sports car. Kind of a similar concept in that a greater mass takes more energy to move itself than that smaller mass. That's kind of all in number 6. So I'll give you a second to type in an answer there. And then we'll look at 7. All right, so how does speed of particles change as you increase temperature? We're just going to look at the speed right here on average speed up in this upper left corner. Going to increase the temperature. What is happening to the speed? You can see that our speed is more than doubled with that added heat. A greater temperature. And we lost our lid. But then opposite. What if I take heat away? What if I cool this off? Apply an ice bath and take some of the heat out of the system. Do you think that the particles could hit 0? Do you think they could stop? At what temperature would it take for the gas particles to stop moving? Let's just see. Let me see. Our average speed is still 150 or 130 for the larger and 300 for the small, lighter particles. moving awful slow. Notice our temperature, it's at 3 Kelvin. And we would not be able to achieve that temperature here in the classroom. It would take a serious research chemistry lab in order to be able to do that. But in the virtual situation, we can see it. You can see even at 0 Kelvin, we still have movement for just a little bit. Let's see if we can get it to 0. And you can see that speed is so slow. 4 meters per second for these particles is slow enough that people could look at them. But then we're still reducing speed as long as that ice bath, it wouldn't be ice bath, but to get it to that temperature, as long as we are getting it to that 0 Kelvin, then we can look at, that's how some of those, how some of the atoms research can be done. Nope, there we go. The heavy particle reached 0 meters per second. So at 0 Kelvin, still took us a minute to get all the way stopped. All right, so let's heat up our particles again. Applying heat causes the speed to go up. Maybe we broke it. Let's reset. Oh, nope, we had more speed. We're adding heat. So we have to remember 0 Kelvin is absolute 0. That is where nothing can move. There is no heat. All right. We won't bore ourselves with trying to get to that. But number 7 said, how does speed of particles change as you increase the temperature? Increase the temperature, we get faster particles. Decrease the temperature, we get slower particles. All right. So I do want to bring over the instructions for submission. Each question, so it's worth 5 points. Please use complete sentences and evidence from the activity. To submit as a text entry, you should already have those done. You're going to just hit submit. But if you've got a Google Doc, I want you to please submit as a PDF. Okay. Then after that, we'll have some time to work on gas laws. But some of you have not done states of matter CK12, so please get that accomplished.